Today I'm going to be trying to teach you guys how to solve the maximum subarray problem on LeetCode. This is a dynamic programming problem that gave me a lot of trouble, so hopefully I can explain it well. Okay, so let's write down 2, 1, negative 3, 4. So, let's see here. 2, 1, negative 3, 4. Uh, Negative 1, 2, 1, negative 5, 4. Negative 1, 2, 1, negative 5, and 4. So this is the array that we're given. And what it wants us to do is uh, find find the contiguous subarray that has the maximum value. So for example, negative 2 and 1, that subarray, the sum would be negative 1. 1, so, it could be the whole subarray, so the value of the whole subarray, or the value of just these two, or the value of these three, or the value of these. It's basically asking the largest value subarray, the largest sum of all the subarrays in the whole array. So for example, this one, it would be this little section right here is the largest sum of all the subarrays. So it's uh, these two count, so it's just 6. So we have it here. So basically what our solution is going to be is to make, so kind of what we're going to do is we're going to have a math dot max, and we're going to have two values that go in here, of course, and we're going to make a new array. And I think the first one is negative 2, not 2. Yeah, so this is a negative 2. Now we're going to make a brand new array. Okay. So, and it's going to be the same length of nums, which is this array. This is nums. So at index 0, the greatest subarray we have up until this point is itself. So it's negative 2. Now when we get to 1, what's greater? What's greater? Negative 2, which is this value, which we're getting that from here, or um, this value, so it'll be this value plus this value. So negative 2 plus 1, which we're getting the 1 from here, or just 1, which we are also getting from the same place. So up until that point, it's 1. Now we go to the next one. Negative 3. What's what's what would be better to what's the maximum up until this point to start a new one? So let me delete this. Up until this point it's 1. So what would be better? What's a greater number? To do 1 plus negative 3, or just negative 3? Um, Out of those two, the greater would be this one. So this would be negative 2. So now we can delete this. Oops. I don't know what that was. Um, we can delete this and go on to the next one. So when we get to 4, what's greater? This negative 2 plus 4 or just 4? So the 4 is greater, so now it's 4. So now we get to the negative 1. What's greater? What's greater? 4 plus negative 1 or just 4? So so the 4 is greater, but up until this point, um, uh, 4 is still better. But our array is still gonna be the next value. So this would be 3. So now the next one, uh, 2. So what's greater, 3 plus 2 or just 2? So now it's 5. It's because this is better. So it gets put. So now what's better? Uh, Up until this point, it's 5 or 5 plus 1. So 5 plus 1, which is 6. So then, so now what's better? 6 minus 5 or just 5? It's better to have 6 minus 5. So, I mean, it's better to have 6 minus 5, but so up until this point, it's going to be uh, 1. And the next one would be uh, 1 plus 4 or just 4. It would be, the next one would go 1 plus 4, which is 5. So now, so now we have this array completely filled out. Now we need basically the biggest number from this array. So that's basically how you solve it. So now we want the computer to go through this second array and get the biggest number, which is the 6. So now we just have to write this out in code. Okay, so the first thing we have to do is, so for me, definitely step 1 is to read and understand the question. The second step would be, if you're in an interview, ask any questions that you may have. The third one would be to think of any edge cases when you have the problem all figured out. And the fourth thing that's important to do is to uh, oh yeah, the fourth thing that's important is to do is to draw a solution um, on a whiteboard. And then after that, do some coding. And then after coding, you can optimize. And then, oh, after coding, you want to make sure that your tests all pass. And then after you pass the test, then you can optimize. And then after that, you can submit your code. So, like I said, the first thing that we're going to do is we're going to make a new int array. Int array values equals new int array, and the length is going to be nums.length, and then values at 0 is going to equal nums at 0. We know that because of this right here, this negative 2, 2. And then now 4, we want to run through the whole int I is equal to 0 while I is less than nums dot length. We can put either nums dot length or values dot length. They're both the same thing. And I plus plus. So we can do values at I is equal to math.max of values at I minus 1 plus nums at I, or just nums at I. Um, mhm. So now we can try to do arrays dot. We can system out dot print line arrays values, and then let's just return 0. We're gonna get it wrong, but I just want to make sure that this array is working. Um, oh, this starts at 1. So the output is coming out right. So it would be 6. So now what we could do is we can introduce max sum and make that equal to integer dot min value, and then we do for each integer I in values, we can do max underscore sum is equal to the max value between I and max, and we can return the max sum after all that is done. Okay, cannot find symbol max underscore sum. Oh. Okay, awesome. So now this test is passing. Now we can submit it and make sure the other tests pass. Okay, so they all pass. So now that we made sure all the tests pass, now we can try to optimize it, which I can already think of one optimization, which is we can initiate int max sum over here, and we can make it equal to nums at 0, and we can remove this whole thing, and then we can make max underscore sum equals the math dot max. So what we're kind of going to do is while we're running through the first time, we're going to be actively getting the max sum. So values at I or max underscore sum, and this should technically do the same thing, except without having to run another for loop. So yep, that worked as well. Okay, so that is how you solve um, the maximum subarray problem on LeetCode. Thank you for watching.